All right, welcome back. This would be part 3, example 9 of topic 1.15. So a function where results differ. So find each of the following limits. The limit as x approaches positive infinity of 3x minus 2 over the square root of 2x squared plus 1. So in this one, it seems a little bit tricky because again, like you're gonna I'm pretty sure a lot of you guys will attempt to divide everything by x squared, but you do have to remember that here that the square root of x squared happens to be x. So if it's not inside the square root right there, then you should be dividing by x. If it's inside the square root, then you should be dividing by x squared. So make sure you guys take note of that. So here, we're going to look at the limit as x approaches positive infinity of 3x over x minus 2 over x divided by the square root of 2x squared plus 1. Again, everything over x squared, right? So again, if we're outside, then we're going to divide by x. If we're inside, we're going to divide by x squared. So here, what we're going to do is we're going to simplify one more time. So this is going to be 3. So the limit as x approaches positive infinity of 3 minus 2 over x divided by square root of 2 plus 1 over x squared. And again, if you do direct substitution, you'll notice that we're going towards 3 over the square root of positive 2. Now, here we do want to be careful because pretty much when we do the square root of a number, right? So the square root of 9 is always plus or minus 3. So specifically in these type of problems, if we're taking limits to infinity, we want to make sure that we also try the negative part about it. So here, like the limit as x approaches negative infinity of 3x minus 2, right, over something, over 2x squared plus 1 and everything inside the square root. So here, remember you guys, like on the outside, now instead of dividing by, right, so we're taking the other side of the coin, right? This is a plus for the minus. In this case, this would be the minus side. So this would be negative x, negative x. Inside the square root, it still has to be x squared because that hasn't changed. But if you took it outside the square root, then I want to make sure that I double check, right? So here, we're going to simplify. We're going to end up with the limit as x approaches positive infinity, right? Simplify here. That's negative 3. That's positive 2 over x divided by the square root of 2 plus 1 over x squared. And again, as you do the direct substitution, you're going to end up with the negative 3 over square root of 2. So make sure you guys look into those right there. Make sure that if you see a root, that you do the negative part as well, especially if you're going towards negative infinity. All right. Next part, horizontal. So definition of horizontal asymptotes. So the line y equals L is a horizontal asymptote of the graph of f of x if the limit as x approaches negative infinity of f of x equals to L, and then the limit as x approaches positive infinity of f of x also is equal to L. So here, like I said, if you guys remember, pretty much like on the graphs, you can also double check your answers on the graphs if you have any questions, right? You can see the horizontal asymptote. So let's try to find the equations here for all of these. So if we do apply the limits on the first one, as x approaches positive infinity, we're going to have 4x plus 5. And then again, I'm going to leave some space because if you notice, we do have a rational function. So that's 2x squared plus 1. And then everything divided by the largest degree in the denominator, which in this case happens to be just x squared. So again, if we simplify this, we'll notice, right, this one goes away with one of those. So you end up with 4 over x. The limit as x approaches infinity. 1 over x, let me give more some time, 4 over x, plus 5 over x squared, divided by 2 over plus 1 over x squared. So again, direct substitution here, you'll find that we have 0 plus 0 over 2 plus 0, which is just 0 one more time, right? So therefore, we can say that the horizontal asymptote is located at y equals 0. And again, if you do the opposite side, you'll notice it's going to be the same thing. If we do the limit as x approaches negative infinity of the function f of x, it also goes towards 0. So I'll leave that up to you guys. All right. The next one again, so let's try the shortcuts. The limit as x approaches positive infinity of 4x squared, right? Well, I don't have to write the whole function down. So this is just going to be f of x. So if you notice here, the leading coefficients, those two are the same. So I know that if it's approaching positive infinity, it's pretty much just going to be the division of those two, right? So 4 divided by 2 is just equal to positive 2. So the limit as x approaches negative infinity of f of x will be pretty much the same thing, because you're not bringing any numbers out of a square root, so you have to be careful. So in this one, it's also positive 2. Again, you can use your graphs to double check. So therefore, y equals positive 2 is the location of the horizontal asymptote. On the next example right there, see, you'll notice that the degree of the numerator is larger than the degree of the denominator. So that should tell you something automatically right there, okay? So here we're going to say that the limit as x approaches positive infinity of f of x, right? It's going to keep growing unbounded, and it's going to go into the positive direction. So therefore, right, it goes to positive infinity. And then the limit as x approaches negative infinity of f of x, it's a not function, so it's doing the same thing. So this is going to be going towards negative infinity. So therefore, it has no horizontal asymptotes. No horizontal asymptotes. Alrighty. And then we got a couple more. So finding horizontal asymptotes. So one more again. So we're looking for the limits as x approaches positive infinity of 8x minus 1. So I'll do this one over the square root of 2x squared plus 1. And again, everything divided. So remember, if it's outside the square root, that would be x, right? So we're doing the positive x here. And then over x squared if it's inside the roots. So here we end up with the limit as x approaches positive infinity of 8 minus 1 over x divided by the square root of 2 plus 1 over x squared. And again, we end up just pretty much substituting positive infinity. We have 8 over the root 2. So that would be our first horizontal asymptote. The next one would be pretty much the limit. So the limits as x approaches negative infinity. So now we're looking at the negative x of the negative part of the square root. So this would be 8x over negative x minus 1 over negative x. And again, remember, if it's inside the square root, then it should also be just positive x squared. So the only thing that's going to be different here is that you're going to end up with negative 8 on top over the square root of 2. And that'll be the location of the other asymptote. All right. So example 12 right there should look a little bit familiar, but when we did it the first time, we were talking the limit as x approaches 0 of the sine of x over x. And that was equal to 0 as well. Or no, it was equal to 1. Yeah, 1. So here we want to see what happens as the limit as x approaches positive infinity of f of x, right? So here, if you end up with pretty much sine of x oscillates between negative 1 or positive 1, right? That's sine of x. And then x pretty much gets larger and larger. So you can think about like a constant on top divided by infinity. So that's going to be end up going towards positive infinity. So the limit as x approaches positive infinity of f of x would also be equal to 0. Again, you can always double check the graph. And if you look at the other side, the limits as x approaches negative infinity of f of x, same thing's going to happen, but in this case, it's going towards the negative side. So we just have a constant over negative infinity. So this is also going to be equal to 0. And then I'll leave those questions to you guys. If you guys have any questions about these, let me know. And then we'll discuss them in class.